Hi, I'm Marty, and I'm a front-end developer. However, by trade, I'm an architect, and I worked in architecture for 5 years before I moved to programming. And firstly, when you're changing career, it's very exciting because it feels like you're 17 again. However, it's not really like that because it felt like, okay, I hit a reset button on my whole professional life, and I lost it all. But it wasn't true, because we know more than we think, and all the professions are giving us many amazing skills. And I hope this talk is going to inspire some other career changers to dig and find all these amazing skills you have. So here we go. These are 4 most important lessons I learned in architecture that helped me be a better programmer. Lesson 1, it's all about the details. So there is this saying that devil is in the details, but my favorite architect had a slightly different approach. He said that God is in the details. And details are awesome, they were always awesome, and we should use them to make our designs better than the others. So these are his buildings. And he took attention to the detail to completely another level. Probably you don't notice that straight away, but if you look on the building, to the building in the left, these are not really box sections like it used to be previously. He used I-beams because lines appear way sharper than the regular box section. And he used them also there. And there's that really cool detail. It's not super visible, but there is a gap between a column and the roof, and it feels that roof is kind of floating. So he knew that details matter, and he used them right. And details often are more important than the vision itself. So if our vision was to create vertical lines, it takes just one detail, one line, to spoil our vision. So we talked about details in design. How about the code? Details in the code are, for instance, keeping our code clean. Clean Code, by the way, is the book by Robert Martin. If you haven't read it yet, do it. It's really good. And to keep our code clean, we should name our variables and functions meaningfully. So if we have a variable that stores age, don't name it variable A, just name it my age or user age. And all the functions are small, so they don't do 1,000 things, they do just one thing. And if we need to copy paste any part of our code, it means that probably instead of duplication, we should just keep it in a separate file for separate logic. And if you have meaningful names, we don't really need a lot of comments, so don't have too many comments. Other details could be about organizing your files. So there are rules how you're naming all your files. All of the files are small, and they are not 500 lines long. And code is exactly where everyone expects it to be. So if you have layout.css, everything about layout is in this file. And revise often, because you need to maybe break all the files into 100 other small files. And don't worry about it, just revise often. Lesson number 2 is easy to extend and easy to delete. I want to stress this second part quite a lot. So there was this really cool movement in 60s in Japan called Metabolism, when people believed that cities are living cells. So they wanted to design buildings that are like capsules, megastructures. They can grow and shrink when the city is growing or shrinking. And metabolist architects believe that cities and buildings are not static entities, but ever-changing, organic with a metabolism. And metabolic architecture is designed and built to be replaced when its lifespan is over. Okay, that's about architecture, but with a little bit of magic from Google Slides. Here we go. Metabolist programmers believe that applications and code are not static entities, and metabolic code is designed and built to be replaced when its lifespan is over. So tips for metabolist programmers are: write modular code that is easy to reuse, maintain, and extend. And keep all modules easy to delete. You might not need them one day, and believe me, you don't want to fix 20 files because of one missing function. Lesson 3 is next larger context. So Elias Saarinen is the architect from 19th century And he said that always design a thing by considering it in its next larger context. A chair in a room in a house in an environment in a city play. So if you're an architect and you have to design a school, you need to take into account needs of all school users. So you think, okay, so students are the primary users, and then we have the, let's call them secondary users. So we have teachers and administration, and we have school nurse, for instance, and all the other staff that works at school. But it doesn't end up there, right? Because parents are walking their kids to school every day and picking them up every day. So we have parents as our users. And school is somewhere, for instance, in a town, and it has neighbors that are going to see the school every day. And there are people who work nearby that are going to pass the school every day. And actually, almost everyone in the city is going to pass the school someday. So that's about architecture. If you are developers, so let's say we're designing not a school, but a school app, our user base is exactly the same. So always consider larger user context, not the primary users. It's the same with even Deliveroo. It's not only about its users, it affects all the restaurants in London. So consider larger user context. And the last lesson, I think it's also the most important lesson I got from architecture, is about managing your ego. So just to give you a little bit of background, the first book about architecture is from 1st century, and you can still have a copy of it, so check it. So this gives quite lots of scale. When you start to learn history at university, it's a lot of masterpieces to go through and a lot of masters. And history is absolutely amazing, because if you want to provide meaningful architecture, you need to know the history and articulate it. And you need to know all the masterpieces, learn about the masters, how they worked, what they considered important, and how they achieved their success. So find your masters, learn from them, because in order to become a master at anything, be it architecture, bioengineering, or coding, you must first understand the larger context and history of the work done in the field that you are in. And programming is relatively new, but there are masters and masterpieces, so find them and learn from them. Because your growth as an engineer is limited if you do not constantly learn from experts in your field. And that was actually all, so thank you for listening. If you have any questions, find me on Twitter or on Instagram. Thanks.